Welcome to our presentation. I am Rizwan Saqib, student ID 1202051108.
Myself, Afsana Khair, student ID 1102059094.
My presentation topic is temperature dependence of resistivity. In our presentation, we will discuss how temperature controls the resistivity of conductors, semiconductors, and superconductors. Let us discuss the effect of temperature on resistivity for conductors. To understand the concept of variation of resistivity with temperature, let's discuss the situation in which, say, we are given with a conductor in which there are plenty of free electrons. We talk about the figure that given below. Here L equal to length and A equal to area and rho equal to resistivity of the material. Here R equal to rho into L divided by A, where L by A equal to constant. R is proportional to rho, we can say. At every temperature, free electrons are in randomized Brownian motion and are under continuous collision with the neighbors. So if a potential difference is applied across the conductor, then the free electrons will start traveling towards higher potential because electrons have tendency to move towards high potential. Now if the temperature is reduced, then what happens? Then that randomness of free electrons in the conductor will relatively decrease. So number of collisions or rate of collisions between electrons will be less compared to that higher temperature. So we consider again the electron which will start toward high potential, and we can say that the randomness in its motion will be relatively less. So at a very low temperature of the order of 0 Kelvin temperature, conductor achieves superconductivity. Superconductivity is a state when we can say the resistivity of conductor becomes 0 because no collision are there on electron. Now we can say if temperature decreases, rate of collision between free electron decreases. That implies an opposing force acting on free electron also decreases, and drift velocity of free electron increases. The drift velocity of free electrons increases. If drift velocity of free electron increases, that directly implies here we can say it is increasing because of increase in mobility. Because we know Vd equal to mu into E. Electric field is a constant. Because a constant potential difference is applied, that means mu is increasing. That's why Vd also increasing, and if mu increases, then directly we can state resistivity decreases because the resistivity of conductor is reciprocal of conductivity, which is given as 1 by n into E into mu. I mean 1 upon n E mu. Here n and mu are constant. So if mu is increasing, resistivity will decrease. Resistivity of a conductor increases with temperature according to the following relation. The relation is rho T equal to rho naught into whole bracket 1 plus alpha into del T bracket close. Here, alpha is temperature coefficient of resistance, which is characteristic property of every conductor. For every conductor, the value of alpha will be different. And here del T is temperature difference, where the initial temperature, I mean T naught, is the reference temperature, which is generally for a calculation we take at 0 degree centigrade, or it is 273 Kelvin. Here is the curve that shows us resistivity of the conductor increases with the increasing of temperature. Temperature reading in the x-axis and resistivity reading in the y-axis. The unit of the resistivity is mu ohm centimeter. In this curve, we can see that the resistivity of the conductors varies from metal to metal. For copper and aluminum, it is a straight line, but for iron, it is like a parabola.
Now we will see how temperature controls the resistivity of semiconductors. If temperature increases, more charge carriers, conduction electrons, and holes are produced, and then the material conducts better, so resistivity decreases. Here is the curve that shows us resistivity of semiconductors decreases with the increasing of temperature. Now thermistors is made from semiconductor. This device is designed to a large resistance change for a small temperature change. Here is the figure of thermistor given below. Now we will discuss about superconductors. For superconductors, there will be a critical temperature. If we decreases the temperature, the resistivity decreases according to the conducting materials. But if we decreases the temperature below the critical temperature, then the resistivity becomes zero. Here is the curve that shows us of resistivity of the superconductors decreases with the decreasing temperature, but resistivity becomes zero after the critical temperature. For helium, the critical temperature is 4.2 Kelvin. Thank you for watching our presentation.